Example 1 talks about a particle moving along a line, so its position at any time t greater than 0 is given by the function s of t equals t squared minus 4t plus 3, where s is measured in seconds. When you see t greater than 0, that just means time has to be greater than 0. You can't have a negative time because you'd be going back in time. When you see an equation, s of t, that is the position function, which means it's tracking the position. You can find where an object is using the position function. Position tracks like location at any point in time. So for part A, it says, where's the particle after 2 seconds? Well, if we want to know where the particle is after 2 seconds, you take the time and you plug it in the position equation, plugging in 2 for t. So you can find the position or the location at any time by just taking the time, for in this case, 2 seconds, plugging in that number for t. If you do that in this case, you get -1. Just means that it has moved back wherever it is. This is along a line. It's moved back 1 unit after 2 seconds have passed. Another thing you can ask are any questions about velocity. If it asks for instantaneous velocity, you need a velocity equation. We get the velocity equation by taking the derivative of the position. So we're doing the power rule here, 2t minus 4. This is the velocity equation. And once you have a velocity equation, you can find the velocity at any time. This one's asking for 4 seconds, so we'd do v of 4 by plugging in 4 for t. Looks like that would be 4. Velocity is a rate, so we call that units per second. Could be miles per hour, could be meters per second, it could be, whatever the units are. Last, it's asking about acceleration. Acceleration is the derivative of velocity. So if I want an acceleration equation, I'll do the derivative of the velocity equation. We have that highlighted. The derivative of 2t minus 4 is 2. So now when I go and plug in 4 for my acceleration function, there's no t to plug it into, so I just get 2, and that would be units per second or units per second squared, because we're doing the rate of change.